Good luck with that. Now I see a table full of stuff and a white coat, which can only mean one thing. It's time for the weird and wonderful world of Wonderstuff.
Once again, Zoe Laughlin from the Institute of Making is here. So where shall we start?
We're going to start with some 3D printing. So this is a technology that's been around for a while, but it's now becoming cheaper and more accessible to the stage where you can have a desktop 3D printer now.
At your house?
In your house. And people can print plastics, metals, so gold, silver, etc. But people are also printing chocolate now. So unfortunately, this one doesn't print chocolate.
Why? Where's that one?
That's still in the Institute. But,
oh, well, OK.
This one's our PLA plastic printer, basically, but it can make all sorts of things like this.
Oh, my goodness, what is that?
So this is a interconnected system of cube cogs, basically.
Cube cogs?
But here's one on its own. Have a feel, because it's sort of...
It's like... Oh, it's a bit crazy. Wow. What do you use up? Oh, look. Is it just like a game? It's like
this is just to demonstrate what the printer can do. But you can actually make, you know, practical things like this adjustable spanner. Well,
and is that plastic strong enough to use?
You might not want to use this plastic, but then if you were to make it from a metal...
But it's interesting because if you look from here, which is where it's all being printed from, up the pipe and round the back, and then it's all coming from a little drum of plastic on the back.
So it's like a very sophisticated glue gun. You have the solid material, it gets hot and melts at the tip, at the nozzle, and it extrudes it out and builds it up additively, they would describe it as.
How does it get the pattern?
So you model that on the computer, and you've got a few options. You can either just build it from scratch, and out of your own imagination, or from a design that you've thought of, or you could scan something.
Or you could scan presenters.
Yes.
And we were scanned. And so this is us being scanned
so this
here.
Is like a little, what is that, like a camera?
Yeah, so I've got there a little camera, and we're walking around Philip, and I'm moving the camera across his features, up and down, capturing his image with this special camera, and then this computer program takes that information and it builds a 3D model of whatever it is you're scanning, in this case, your head.
And then it will just build your head?
Do you have a finished product?
I do. Now, you always knew you had a hole in your head.
What's happened to the...
So the likeness...
Wow.
Right, there, that is amazing. That's
really
incredible.
good.
What the hell's happened here?
Well, the scanning, it requires... if something's too reflective, it can't pick it up. So...
Oh, it's your hair.
But you say that now, I think you might have been wearing lip gloss.
Oh, have I got no lips?
The lips... the lips on Holly are a little bit undefined.
But also, what's going on under here?
Well, a very defined jawline. We couldn't...
So between us...
A shiny chin.
What a shiny couple we are.
Aren't they
but
brilliant?
I mean, these scans took us 30 seconds to do.
Yeah.
And if we were being really exact about it, we could have done them again and lit the scene better.
Oh, no, they're wonderful. What a clever little machine. What are you printing there?
Well, these took 2 hours, two days.
Oh! Ow, I felt that.
It's all right, Phil. This took 2 days to print, but this one is just a 40-minute print. So by the end of us going through this, it might have finished. But what it is, it's a little present for Holly.
Is that a ring?
It is.
It's my own diamond ring.
And the box has been printed especially for you.
Oh, my goodness.
You printed the box?
Yeah.
That's incredible.
So this was designed
and it fits
especially for you by our technician at the Institute of Making.
Thank you.
Next up.
So that's, 3D printing.
What's this?
Well, this is a
diamond.
A paintable wire, essentially. This is a paint which conducts electricity, so you can paint this onto any surface and make it conductive.
Wow.
So instead of having to embed wires inside things, you can paint this on. So here's one I painted earlier, just to show you. So here we have a 3-volt battery, and that's the positive side, and this is the negative side, and the charge is running off the battery along the black line.
But so even though it's running off, if you touch it, you're not going to get electric shock?
No, it's fine, and the wood is intuitive. It's simply, once it reaches something, that can make use of the current. So here we've got a little LED light.
And they...
Oh, hang on.
And
there we go.
So what would you use this for?
Well, you could make... so because you can paint it onto anything, you could actually paint it onto woods or fabrics, for example, and make some flexible electronics.
Wow.
So I just did this in the green room earlier, so this is a test. It might not work.
So you can put lights on your clothes?
Yeah, so if I just place that there we go. Ready?
I want a dress that lights up.
Ta-da!
That's so cool.
But this is just a cotton T-shirt.
So when you're at a concert and everyone is rocking their hearts out, you go, wait, look at this.
Dink.
Tiny.
From the stage, they'll be going, wow, look at that.
Brilliant. What's this?
So next up...
I mean, obviously it's a kettle, but I mean, what do we do with it?
One of the things...
I've never seen that. You can get tea out of it.
It's not about the kettle.
New invention. It heats water.
No, that's so clever.
Well, one of the things we do at the Institute of Making is investigate certain properties of materials. And here we've made spoons of different types of metal in order to investigate what they tasted like. So we did some formal studies.
What a spoon tastes like?
Yeah, well, what the material that your cutlery is made out of.
Yeah, because you can
food.
sometimes. You can put it in your mouth. You can
taste it like metal. Yeah.
So we did a formal study into this, but we also then worked with a Michelin-starred restaurant to look at how it interacts with food. And I thought you might like to try some of our special spoons. Please. So we could begin with stainless steel, maybe, just to set the standard. This is the standard spoon that most cutlery at home is made out of.
Do I just put it in my mouth?
Yeah, just have a suck, a normal spoonness. It won't taste anything untoward.
Tastes like a spoon.
Yeah. So we've got stainless steel. This is chrome. This one is the... Oh, you don't have to try them all.
I'm gonna.
OK.
Oh, yeah, that tastes different.
Does it?
Yeah, it does. It almost tastes colder, weirdly.
OK, let's try and remember which one. And this one is the tin.
Tin spoon. Oh, that's horrible. Can you not taste that?
There's no difference, Holly.
I'm telling you,
well, one of the things we found, there are certain people are more sensitive than others to these things.
I have a very sensitive taste.
This one is silver.
The other day.
It's a nose, I said.
Well, that's really horrible.
That's
silver.
A little bit more tin.
It almost tastes...
You can
but I can taste that with the tin.
Can you?
It almost tastes like it's almost got electricity in it. It tastes that sort of taste.
Gold.
A gold spoon?
Can't taste anything in there. That's lovely.
Yeah. So gold is totally inert.
Gold it is.
Yeah. Well, why don't you try gold with some of the food? So have a little bit of this yoghurt. This is copper. We'll hold on. Or you can try the copper. Yeah, try the copper next.
OK.
Anything?
Nothing.
OK, now maybe into the tomato soup.
What, copper in tomato?
Little...
Ugh! That's really metallic.
Oh, it makes the whole flavour of the soup taste completely
I don't like that.
No, it's horrible.
Why does it taste funny with food, but not on its own?
Was it reacting with the acid or something?
Exactly, yeah. The copper is reacting and you can taste that in your mouth. It's really metallic.
Yeah.
But it does it with the silver, the zinc, the other materials will react. Even stainless steel slightly will react with these acidic foods.
What about this one?
The gold, that's peach yoghurt, so it's much nicer. You can try that with the gold, or you could, if you want to wash your copper spoon, you can have another go. Maybe
so it doesn't work. It
won't be quite as bad, I would hope. But maybe now you've got the taste in your mouth, it'll be difficult.
No, it's not bad at all. How fascinating.
Oh, that's nice yoghurt.
Help yourself. So, but now I've made a couple of other special spoons.
What do these ones do?
These aren't to be eaten because they have a very specific property. So this is a metal called gallium.
Gallium?
Yeah.
I love the name of it.
Now, I'm just pouring out... Imagine this is a cup of tea. We'll keep it clear so that you can see what's happening. But now you go to stir your cup of tea.
What, me?
Yep.
Oh, it's disappeared.
Look at that, it's melted.
Wow.
That's a rubbish spoon then, isn't it?
Yep. But that tells you that you've got to pick the right material for the right function that you want.
Yeah,
and be that what you want it to taste like, or you want it to actually be able to survive in a hot liquid.
Almost.
Yeah.
It is like solder,
yeah.
But it just needs... It'll actually melt in your hand if you've got warm enough hands. It needs about 30 degrees to
Gosh, you
start
could do
to
some
melt.
good spoon bending tricks with that, couldn't you?
Yeah.
There's a glass of water here. What's that for?
It looks like a glass of water, but it isn't. This is a liquid called a fluorocarbon. Now, fluorocarbon liquids are totally inert to electrical current. They don't conduct electricity.
But when they become chlorofluorocarbons, CFCs, that's what made the hole in the ozone layer.
It is.
Right, OK.
But this actually evaporates and isn't very good for the environment. So after I finished, I'm putting it back in a bottle with a lid on.
Oh, OK.
But because it's inert, it actually doesn't conduct electricity. So unlike water, you could actually... Where have we got? Just pop in your...
No, you're not going to do that.
Mobile phone.
You're
now,
joking. No, actually, there's something in me just pinged again. You do something like that.
I'll give it a ring and see...
Why doesn't that destroy it?
Well, we may have. If it was water, we wouldn't yet know. If you're going to the loo and your phone pops down the toilet, you know, it's not until afterwards you try and turn it on that it'll be a problem. But I will give this a call and it should... Watch the display.
I need... Oh, it's vibrating.
Ringing. It's ringing.
And you get it out and answer it, maybe?
All right. If I touch that with my head, is it going to dissolve my ear?
No, it's fine. Just press the... Oh.
It's still working.
Hello?
Hello.
Bang.
Hi, Holly. Hi.
It does, it works.
Amazing. Thank you very much.
You're welcome.
As always.
Wow.
And you don't have anything at the Institute of Making to get rid of nasty stains, do you? You seem to have dipped my sleeve in the
I'm sure we could find something.
tomato sauce.
They'll have something.
Thank you very much.
Wonderful,
Oh, let's see how that
always.
went on. Let's see
Oh,
how
yeah,
that
we're
went
doing
on.
it again.
It's nearly finished. The camera from the front is a good shot because you can see the ring coming
far
down.
at ring, it's nearly there, it's nearly there.
Half of the circle to go.
Well, if you want to find out more, then you can visit the website. Isla Fisher is here after the break.